Good morning, good afternoon, good evening. I'm Ed Wood from Cambridge Intelligence, and we'd like to welcome everybody to this webinar, Supercharged Graph Visualization for Cybersecurity. We've had a great turnout. We've got, I think, 8 time zones, folks from 8 different time zones participating over 3 continents. So thanks very much for your time. So we'll try and keep you entertained and informed for about the next 45 minutes, 30 minutes of content, and then some time for your questions. So the agenda that we have for you today is we're going to make a very quick introduction to the company, the people, and our mission. We're then going to go through and share what we've learned from helping our customers get value and insight from their cyber data, and also our own experiences. And we'll try and explain some of the challenges we've observed on that journey. And then I'll hand over to my colleague Corey, who will do some live demos with real data, and then also share some useful patterns and techniques that we've discovered for coping with cyber data. Then we'll have some time at the end for your questions, and thank you very much for those that have submitted some great questions in advance. A little bit of housekeeping: the webinar will be recorded. For folks attending, you'll get a link from the video tomorrow, and as we go along, please submit any questions that come into your mind via the Citrix control panel. Okay, so it's not a product pitch or a company pitch, but we thought we'd just have a very quick introduction to the company. So we're a young company, but we're totally focused on supporting our customers extract value from connected data. So I'm speaking to you here from sunny Cambridge in England. We also have a growing US presence, and we serve and support customers across the world. So the combination of our award-winning products, developer services, and expert know-how helps organizations understand their connected data. And on the topic of award-winning, we couldn't help but share the news that we learned this week that we've been awarded Gartner Cool Vendor status for 2016. So we're very delighted about that. Then here's just some of the brand names that we're proud to have as customers. You can see at a glance there's a very broad range of vertical markets represented there. The big 3 markets for us are the intelligence community, people looking at fraud and fraud detection, and then the increasingly significant cyber market, which is obviously the focus of this webinar. Then, just to introduce, again, just one slide to introduce a product that we'll be demonstrating later on. This Keylines is the product that we offer. Keylines is a JavaScript SDK that helps you quickly and easily embed visualization into your application. So for the developers and technical folks on the call, the proposition is that we give you great documentation and support, and we're about giving you a really massive reduction in the development time, an effort that you'll expend to embed this great technology into your application. And then for end users and analysts, they get great performance, an intuitive experience, and a rich toolbox of analytical mechanisms to help them unlock value in their data. And then just a very quick introduction to graph data. We know there's some folks that are new to us on the call. So a very quick introduction to the terminology around graph visualization and data. So the picture that you can see on your screen is data recovered from the Enron investigation, and it represents email exchanges between executives at Enron. So the things we call nodes, the circles, represent people, and then the links are email exchanges between them. So people who send the most emails are not usually the most important. If we had represented this graph and scaled the nodes by the people that sent the most email, the folks down the bottom or a corner would be shown enlarged as they've exchanged a lot of email. But what we've done is used an algorithm to scale folks by their seniority, as discovered by the number of shortest paths that they're on. So it's a simple visualization, and this is a static visualization, not the dynamic visualization you'll see later, but it gives you a very quick introduction to the terminology of graphs and graph databases that we'll expand on in a little bit. Okay, so now we're going to make a connection between graph visualization and the domain of cybersecurity, which I'm sure many folks on the call are very expert in. So the good news is that cybersecurity data structures often fit very well with graph entities and visualizations. So we've taken some entities which I think will be familiar to you, which could be candidates to be represented as nodes in a visualization. So typically machines or people or data centers would be represented as nodes. And then there are topics, there are entities which you might frequently represent as links, which could quite often be things which connect or flow between the entities. So things like attack vectors, things like data packets, things like emails would be candidates to be links. So by representing these entities in a graph in this way, you get the visual and interactive representation you get can allow you to quickly and efficiently uncover patterns, trends, and anomalies in these complex data sets. And then just a couple more slides before we hand over to Corey. And these try and share what we've discovered, both through the interaction with our customers and also through our own work as to what are the biggest challenges of cyber data. So we think there's three big challenges. The first is just the sheer volume of data that exists. So there are a huge number of security events generated by CM systems and other systems, which typically generate events at the resolution of milliseconds, typically store these data in disparate silos, and already you're starting to get an unmanageable problem. So the challenge with this data is to try and detect unusual behavior inside these very quickly terabytes of data from sources including IP logs, network logs, communication logs, and web server logs. So the first of these three challenges we assert is just the sheer volume of data. And then we think there's a couple of other interesting challenges which are related. So complexity is reflected by the web of interactions between typically human actors and machines. So the simple event of a user logging into a machine and maybe copying a file or moving a file may generate hundreds of events, may generate hundreds of alerts, and very quickly a simple event becomes something that's massively complicated. And the third and related challenge, we think, is related to noise in the data science or the information theory use of the word noise. So we might be looking for a signal, which is one malicious event in a sequence of millions and millions of benign events. So to recap, the challenges are very real and large. So the volume of data, the complexity, and the noise. So that's just a very quick introduction to the domain, to our company and product. And now we'll hand over to Corey to demonstrate some techniques we think are useful in terms of overcoming some of these challenges and getting to the value and insight in the data.
Hi everybody, my name is Corey Lanum. I handle the commercial side of the business here at Cambridge Intelligence, and I thought it would be helpful to show you a few things, live examples related to the types of challenges that Ed's been talking about and techniques that we found in applying graph visualization to cybersecurity type data. So the first one he mentioned, let me share my screen here, is the sheer volume of data. So typically and historically, graphs have been used in analyzing social networks. The first example that you saw of internal emails with an organization only had 30 or so nodes on it, and looking at, say, Facebook or Twitter followers of individuals could be, just a few dozen examples, or even up to a few hundred, and that's pretty easy to plot out each individual data endpoint itself on the chart. But cybersecurity is a different realm. Oftentimes, we've had customers who are looking at individual packets, IP packets across a network, and trying to figure out the source and destination of those. And it is completely unrealistic to represent each individual packet as a node and a link on a graph. You're not learning anything by looking at volume at that level of volume at that level of detail. To give you an example, this is very common when we come across people who try to load all of their data into a chart and try to visualize that all at once. So this isn't even that large. This is 5,000 nodes and 5,000 links in a Keylines chart where everything's linked to almost everything else. And I'm sure you recognize that the knowledge gained or the value gained from looking at this amount of data crammed on the screen all at the same time is quite limited. I will take make a brief pitch for our WebGL capability, which we've just added to Keylines, which improves the rendering performance when you have very large graphs. I'm not positive about the speed of the GoToWebinar, whether you can see that I'm still getting 50 to 60 frames per second here when I'm zooming out or dragging nodes around on this chart. That is a feature that we have in beta at the moment, but are aiming to have the production quality out quite soon, sometime later this year. What I'm going to do then is show you some examples on when you do have that kind of data volume, how can graphs be useful as opposed to just drawing them all on the screen at once. And also talk about different data sets that we've come across that are cybersecurity related that lend themselves well to looking at as a graph. So the first one that we're going to look at here is malware and malware propagation across different servers. So what we've done is we've taken the nodes, represented them as hosts and IPs and ISPs, and these are hosts that were known to be infected by particular malware families that you see over here in this pane on the right. And the link between the host and the IP address is color-coded by the family of malware that it was infected by. And so this is very common both in cyber-type data and in fraud data, is that you see a lot of isolated events with just one or two nodes and links that aren't connected to the rest of the graph at all. So for example, if we look over here, here's an American ISP because we use the flag of the country where it's based to represent it on the chart that has a single IP address that has a single infected host. Generally not something we might be particularly interested in. But if we look at some of the ones that stand out visually, for example, up here we've got this Russian ISP that has a single IP address but has, I don't know, 5 or 6 different infected hosts all with the same malware. And that's because Zeus is capable of showing different host names associated with a single IP address. And that stands out because we've taken the size of the node and bound that to the number of different hosts that are connected to it. So that's easy to see visually even when you're looking at all of the data all at once. And then the other thing that stands out are these dense clustered networks too. So for example, if I look over here at this French ISP in the upper left, you see that it has a number of different IP addresses infected with a number of different types of malware, and each one of those IP addresses has a host associated with it, one or more hosts associated with it too. So this is a very serious issue that's worthy of further investigation that stands out when we look at this data in a graph visually. Similar with this German example up here at the top, we have a number of different IP addresses and a number of different types of infected malware on that ISP. So something interesting is going on there. And then across the bottom here, you see the time bar. This is another way to pare down on the amount of data that you're trying to analyze all at once. Especially with log data, every single instance in the log is paired to a specific date and time that you can use to try to understand patterns over time and to try to minimize the amount that you're drawing by looking at individual windows of time. So what we see here, this is a publicly available data set, is that infections of the types of malware that we're looking at were quite low for the first 3 years and then really started to ramp up in 2014 and 2015. And I can interact with the time bar too. So if I wanted to look at, say, just the second quarter of 2015, I filtered out all of the items that didn't occur, all of the infections that didn't occur in the time window that I'm looking at. So now I only see these 3 months. I can drill down even further to look at instances of just a few days. And that gives me much smaller amount of data that I have to look at the same time to better understand what's going on. I may not necessarily care about things that happened in the distant past and focus on just what happens now. I can also actually animate. This, to be fair, is a little bit of eye candy, but it can really be helpful because it helps show how patterns are changing or how your data is evolving over time. In this case, I'm watching the chart grow as we gain more and more infections and adding them to the chart as time goes by. And the filtering is important not just because you can filter to individual windows of time and look at all of your data, but you may want to look at individual subsets of the data as well. So let's look at the pattern of Zeus infections. So we see those brought to the foreground here, whereas all of the other types of malware are blended out into the background. So if we wanted to focus on just that subsection of my data, I can see that here, but then I've also superimposed that on the time bar. So I can watch Zeus infections grow to a peak around the end of 2014, but then taper off as we've gotten control over it and found ways to mitigate that. In contrast, maybe, I want to look at Feodo. Feodo version D was 0. It wasn't even known until 2015 when it started spiking, and spiked much more toward the end of the year. So what we're able to do here is allow you to compare and contrast different types of malware across and looking at those both over time and over what's linked to one another. So that gives you a sense of the capabilities of the filters and how filtering can really help when you load a lot of data into Keylines, understand what's going on in the subsections of the data that are relevant to the job that you're trying to do. As another example of that, let's look at this demo, which is public data breaches in 2013 and 2014. So in this case, what we've done is a bit of a different data model here. We've taken the companies that have had data breaches over those 2 years, represented them as nodes on the chart, but as the other end of that link is the vector for that breach. So was this a software developer? Was it an activist group? Was it an employee of the organization? The other thing that we knew was or something like that. Physical access, somebody broke into the site. And so that's color-coded by the link, but just like we saw with the malware, we may want to filter and look at the individual vectors that we're interested in. So here are the instances where the user or the data was breached by accessing the site physically. Then we can also do searches on the data too to zoom in on the area that we're interested in. So in this case, I'm interested in the Home Depot. I can see the Home Depot. If we remember, there were some public, very public data breaches of that company in 2013. We can see the various different vectors that were used and the individuals that were used to obtain access to that data. And then we see the results just like we did before on the time bar here. So if I want to see only the first quarter of 2014, here are the breaches that took place in that quarter. I can also, just like I did before, look at instances of, say, basic technology being used or advanced technology being used in that quarter and filter basically just to look at the level of data that I'm interested in. So there were a couple more things I thought would be helpful to show you where we don't actually have publicly available cybersecurity data to show, but I thought it would be relevant anyway. So you'll just have to imagine how these capabilities might look when applied to that type of data. So if we look here, this is an example of communications between individuals in various countries. And it's a fairly complex chart and not so easy to understand at this level. It's, I think, 220 nodes on this chart. And we may not necessarily be cared. We've used the flag of the country that that person lives in to represent them on the chart. Maybe we don't necessarily need to see all of the data all at once and the individual data endpoints themselves. Maybe we want to group them together and look at how the groups themselves were connected. This is particularly relevant when you're looking at, for example, network IP traffic. You have these different layers of IP traffic down to the physical cabling and the hardware all the way up to which applications are communicating with which else. Depending on the level of investigation that you're doing, may be relevant to look at the data at one level or another. So in this example, we've grouped together the individuals from each country to look at how the groups themselves are connected. 70 in Afghanistan, 56 in France, and we've used the width of the link to show the number of communications between those groups. So there's nothing in the data that tells me lots of people from Afghanistan are working with people from France, many fewer with people from Saudi Arabia. But the grouping allows us to see the graph at that level, but then to zoom down to the level that's of interest to you. So let's say we want to focus on Morocco. We can uncombine Morocco and see how those individuals themselves are connected to the rest of the countries on the globe. So that's what we call combinations, but is also frequently called grouping in graph technology or terminology. The last thing I'll finish up here before handing it back to Ed is our geographical component. So oftentimes when you're looking at cybersecurity data, in addition to having a date timestamp associated with it, every entry in that log has the exact time and date that that log event happened. But also oftentimes you have a geographical space. You can geolocate IP addresses, for example. You may want to look at where certain traffic is originating or things like that to look at patterns. And so what I have here is an example that's public data of, it's not cybersecurity data, it's of bike rentals actually. So in Boston here, we have a system that's common in many big cities where you can rent a bike at one location and return it to another. And so that can be modeled as a graph, although this looks a lot like the performance example that I showed you earlier where everything's linked to everything else, because we're looking at all of the data at once. But when we try to pare down on the amount of data that we're presenting, it really gives a much better sense of what we're looking at. So we have a bunch of filters here to show me, say, maybe only trips that are longer than an hour. And here are the only bike trips where somebody has had the bike for longer than an hour and where on the map they rented them, because each one of these stations has a physical location on the globe. Again, with the filtering, we may want to look at only trips that originate or terminate at a specific station. So for example, Faneuil Hall has a lot of tourist traffic, whereas South Station is the train station, so we see a lot of commuter traffic. And you can see the different patterns over the time of day. And then the time bar, in addition, is showing us general patterns over time. So for example, we see bike traffic growing over the course of April, which is unsurprising for Boston. It was very cold at the beginning of the month and generally quite pleasant toward the end of the month. But then we also see some interesting examples. We see very little traffic here on April 12th compared to all of the other days of the year or of the month. We see the trips that were taken there, and it's a small fraction of the surrounding days. So that's worthy of further investigation. And in fact, if you just Google what happened on April 12th, you can see that there were tornado warnings and severe thunderstorms. So I'm surprised that as many people were biking as there were, but you can understand better why there was a drop-off in traffic that particular day. So by combining geographical analysis, focusing on just the area of geography that you're interested in, looking at just the window of time that you're interested in, and then filtering based on the type of traffic that you want to focus on, you can really better understand what's going on in the data without having to actually plot every data endpoint on the screen at once, which, as you've seen, becomes quite unwieldy as you get to extremely large volumes of data. So what I'm going to do now is I'm going to hand the baton back to Ed to talk a little bit about some of the new features that we've been adding to Keylines, and also to take any questions and comments that you may have.
Thanks a lot, Corey. Okay, so I think I'm going to have to share my screen again to get things to work. Show my screen. Fantastic. Okay, welcome back to Cambridge, England. Thanks very much, Corey. That was great. The product that Corey was using for all those demonstrations was Keylines. Just a very quick update on that product. So we just about a month ago released Keylines 3.0, which had some features and capabilities very much directed towards the cyber market. The thing that Corey demonstrated very nicely was the WebGL capability, which makes a huge improvement to rendering speed and increases massively the size of data sets that you can use. So you get really fluid and responsive behavior, even with many, many thousands of elements on the chart. WebGL is a technology that's in alpha, It is supported by all the big browsers and most devices, from laptops through tablets right down to mobile phones. We've had fantastic response to it and really great feedback that it's really helping people deal with big data sets. Corey showed 2 of 3 really nice cyber demos that are built into the toolkit now. There's a third one that's all about vulnerabilities, which is very interesting. And then there's an awful lot of other good stuff in the release, but one headline feature based on requests was a new directive for people developing JavaScript applications using Angular. So Keylines is available. You can get access to it for free, and all of the demos that Corey showed you are available with the toolkit, including the source code. So you could very quickly get stood up, take your own data, and play around with some of the techniques that Corey showed. Okay, so we had some great questions in advance that we'll try and answer, and I think we've had at least a couple of nice new questions come in, and we'll try and deal with those on the fly. So the first question was, can Keylines work with real-time data? Do you have any recommendations for how to do this? So yes, Keylines very much can cope with real-time data. There are some capabilities which very well suit that. So there is a layout option called tweak, which lets new data come into the graph and get a nice, smooth rendering. So you don't get a jarring experience. You could offer in new data, which might be malware or whatever the data set is representing, and you would get a smooth and fluid representation of it. As ever, we would remind folks or encourage folks to think about the capabilities of the human brain. Don't overload your analysts. So there's some nice techniques available in the product, like combinations that Corey showed, which could take maybe many elements and combine them maybe just temporarily to give the analyst some overall view of the data. And there's also some nice capabilities to foreground and background elements on the chart to draw attention to things. So great question, thank you very much. The next one was about a really good question about what's the maximum number of nodes and links that you can handle. Good question. So it's a good number, even using HTML5 canvas. We can comfortably cope with thousands of elements, even on a modest laptop. WebGL really increases that by an order of magnitude. So you could offer, if it's sensible, tens of thousands of elements to a user. And then there are techniques where you could have data available in the graph, but actually hidden from the user. And in that case, you could even have 1 million elements available, but only a subset of those you would choose to make visible. So that's a technique. When there's a really massive data set, you can actually hide stuff and give the analyst a sensible number of things to manipulate. Okay, more great questions submitted in advance. How easy is it to change the shape, design, and layout of nodes and edges? So it's very easy. We provide support out of the box for a bunch of different shapes. You very often will want to have some custom graphics, so you can have an image that represents the particular element for a node. You can make use of font icons, and there's libraries of thousands of really great icons that you could associate with the node. Layouts, we provide 6 different automated layouts. The most popular, or maybe the most common, being things like a hierarchy when the data has that kind of form. Then a question about how well do things cope with a machine with a particular graphics chip. So WebGL is the technology where we unlock the GPU that exists in most devices. So there is some element of experimentation. It will depend on the browser you're using. It will depend on the exact model of hardware. But both Corey and myself are using regular MacBook Airs, so not a very high-powered machine, and you get the kind of performance that Corey demonstrated. Okay, we've got some live questions. Let's see if we can deal with at least a couple of these on the fly. So one question was, somebody liked the demos that Corey showed and was curious about where we got the data from. We are a visualization company. We don't have, I'm sure many people on this call, companies will have all sorts of fabulous sensors and fabulous data sets. So we've used public domain data. There is a very good Swiss security blog called abuse.ch. Some of the data came from that. Verizon, the data breaches report came from the famous Verizon report. And then there's also a nice security blog called Contagio, and we got some data from there. Again, if you sign up to Keylines, you look at the demos, we always acknowledge the data sources we've used, so there's a reference there. If you have any questions or you'd like some links, then please contact us. Let's have a look at how much of the manipulation of the graph can you do with Keylines. So I think the philosophy that Keylines supports is allowing a very, very interactive interaction with the data. So we want to provide the tools that let the analyst have an almost playful relationship with the data, to use the human brain's capability to find those patterns and use the ability to see kind of almost intuitively outliers, things which look anomalous, and then allow interaction with the chart to follow their nose and find those suspicious patterns. We've had a question about is it our own code? Have we written this ourselves? So yes, the JavaScript, our intellectual property is encoded in the JavaScript that you license. If you become a happy customer or evaluator of Keylines, then you license access to the JavaScript which runs inside the browser and provides all these fabulous visualizations. We had a great question saying somebody enjoyed the webinar, but will we cover alternate use cases? And they talked about financial fraud, and the answer is yes. We will be doing some other vertical market webinars. This is the first of a series, and we will absolutely be doing a financial fraud one later this year, date to be announced. So I think that's all the questions we've had. So thank you very much for those. They were great. We will gently wind our way towards the end. So thanks very much for everybody's attention. So just to recap, we started off by trying to share our view about the not inconsiderable challenges with cybersecurity data. So just the sheer volume of it, the complexity, the subtle interaction of human actors and machines, and the fact that things are happening over time. There's the subtle interactions in terms of when things occur as well as where they occur, and also the data is almost inherently noisy. We're looking for tiny events, maybe in a sea, tiny suspicious events in a sea of benign events. So we suggest that for a good cybersecurity visualization, you do need to think about things, you need to think about the visual model, and you need to think, probably most of all, about the questions that you want to ask of the data. What do I want to get out of this? What answer do I want from this data? We think there are techniques and functionality available in our product to help you do this. So thinking about layouts, thinking clearly about filtering, maybe making use of combos. If we've got some data which kind of explodes into a kind of fireworks show, maybe even temporarily I could combine those into a single entity to let me see other interesting patterns in the data. Corey did a great job of showing where we have data that varies over time, how you can make use of the time bar to explore that dimension. And then some data will be, for some data it will be appropriate to actually think about the where, to look at the geo side of things. Maybe it's which data center or which IP, what's the geolocation of this IP address, and maybe it's helpful to see that on a map. So we think we've got the tools, and we've had some great success with some of our customers to deliver tools to help you work with data at this scale. So we think data visualization is the answer. We may be slightly biased, but we'd love to help you. If anything we've said is interesting, if some of the problems we've described kind of feel familiar or resonant, we'd love to hear from you. So I think that's the end. So thank you very much for joining us. You can contact us at info@cambridgeintelligence.com. Any feedback on the webinar, any questions that you've had coming from listening to us, we'd be delighted to hear from you. And with that, I think we'll say good morning, good evening, good afternoon, good evening from a sunny Cambridge. Goodbye.